Alright, today you are going to be learning about the quadratic formula and the discriminant. This is another way to solve quadratics. We've already learned to graph quadratics to solve them, use our equation knowledge to solve them. We've learned to factor them and solve them. And sometimes those methods do not work, so we have to use the quadratic formula. So by the end of our time today, you should be able to solve quadratic equations using the quadratic formula and be able to find the number of solutions for a quadratic equation. Now I'm going to tell a little story here about the quadratic formula to help you remember this quadratic formula. So we say x equals, and then there once was a negative boy who was all mixed up. So he went to this radical party. Because the boy was square, he lost out on 4 awesome chicks. So he cried his way home when it was all over at 2 a.m. So the quadratic formula here is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So in our quadratic equation, when we have the a value, the b value, and the c value, and we're not going to graph it, we can't solve it with our equation knowledge very easily, and we cannot factor it, we choose to sub in a, b, and c to this formula to find out what our x value for our vertex is. So once again, we use that standard form of the quadratic formula, and we can only use that if we have it in standard form of ax squared plus bx plus c equals 0. So then we can use that quadratic equation of x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So I'm going to go ahead and show you an example here. If I have 3x squared minus 7x plus 2 equals 0, and I am trying to find the solutions to this equation, in order to use the quadratic formula, I must know that a equals 3, b equals 7, negative 7, and c equals 2. And then I would just fill that into my formula. So I would have x equals positive 7, negative 7 is positive 7, plus or minus the square root of negative 7 squared minus 4 times 3 times 2, all divided by 2 times 3. So I'd have 7 plus or minus the square root of 49 minus 24 all over 6. Well, I would simplify this and say 49 minus 24 is 25. So I have 7 plus or minus the square root of 25 over 6. So I set this up for simplifying still, but then I set it up to my 2 solutions. So I now have 7 plus or minus 5 all over 6. So one option is 7 plus 5, which is 12. 12 divided by 6 is 2. Okay, and my other option is 7 minus 5, which is 2. And 2 divided by 6 is just a fraction in simplest form, so 1/3. So x equals 2 and x equals 1/3. All right, taking a look here at the second question. This one is not quite in the quadratic standard form, so I want to get it in that standard form first. So I'd subtract 5 from both sides and have 2x squared minus 4x minus 5 equals 0. So now I know that my a value is 2, my b value is negative 4, and my c value is negative 5. So again, I'm going to sub these into that quadratic formula to solve for my solutions. So negative 4 plus or minus the square root of negative 4 squared minus 4 times 2 times negative 5 all over 2 times 2. So I'm going to simplify that, and I get 4 plus or minus the square root of 16 plus 40. Because negative 4 times 2 is negative 8. Negative 8 times negative 5 is positive 40. And that is all over 4. I'm going to simplify that. I get 4 plus or minus the square root of 56 all over 4. Now, the square root of 56 is not a perfect square root, so I can simplify that by taking out a perfect square root. So 4 times 14 is 56, so I can say that the square root of 56 is the same as the square root of 4 times 14. The square root of 4 is 2, so I can now write that it's 4 plus or minus 2 times the square root of 14 all over 4. So I would have 4 divided by 4 is 1, and then would be plus or minus. I could simplify 2 over 4 to 1/2, so it would be the square root of 14 over 2. Now, I can find those decimal answers. Sometimes you want to leave your answers as a decimal. Sometimes you want to leave them in that form if they do not work out to be a whole number. So in order to find my 2 decimal answers, I would take 1 plus the square root of 14 and then divide by 2. And I would also take 1 minus the square root of 14 divided by 2 to get my 2 answers. And if you found those, you would get that x is about 2.9 and x is also about negative 0.9. All right, so I want you to go ahead and take a look here at 2 problems. I want you to try them by yourself. Go ahead and pause the video, and once you're done pausing the video from your work, I will go through the work for both number 3 and 4, and you can see how your work compares to mine. Make sure that you put both of these in standard form first, and then determine the A value, the B value, and the C value, and then go through that work that I went to. If you need to go back to my 2 examples to see how I filled that in and how I simplified that, feel free to do that. But please do not go on to these next 2 answers before you have tried number 3 and number 4. If you do not have a calculator with you, go ahead and get a calculator to help you get down to that decimal answer if you want to, or you can just leave it in radical form. That's up to you. All right, if you take a look here at number 3, the first thing you needed to do is to subtract the 10m from both sides so that you could get that standard form quadratic equation. So we have 3m squared minus 10m minus 8 equals 0. So the A term was 3, the B term was negative 10, and the C term was negative 8. So if you plug that in to your formula, we're not solving for x this time, we're solving for m, so that's why I have m equals to the formula. So you're going to sub in negative 10 for b, so that thus becomes a positive 10, because negative 10 is positive, plus or minus the square root of negative 10 squared, which is 100, minus 4 times 3 times negative 8. And negative 4 times 3 is negative 12. Negative 12 times negative 8 is positive 96. Okay, and that is all over 2 times 3, which is 6. So at the top of the right hand of the screen here, you see I have 10 plus or minus the square root of 100 plus 96 all over 6. Well, 100 plus 96 is 196, which happens to be a perfect square root, so I can simplify that down to 10 plus or minus 14 all over 6. So one answer is 10 plus 14, which is 24, divided by 6, which is 4. And the other option is 10 minus 14, which is negative 4, all over 6. And negative 4 over 6 simplifies to negative 2/3. So m equals 4, and m equals negative 2/3 for number 3. All right, if we take a look here at number 4, that you were to try it by yourself as well, If you take a look here, it was not in standard form, so you want to subtract 16x from both sides. So you get x squared minus 16x plus 64 equal to 0. So your A term was 1, your B term was negative 16, and your C term was 64. If you sub in negative 16 for B, you have negative 16, which turns out to be positive 16. And then plus or minus the square root of negative 16 squared, which is 256, minus 4 times 1 times 64. And negative 4 times 1 is negative 4. Negative 4 times 64 is negative 256. So underneath that square root, we have 256 minus 256. And then on the bottom of our fraction, we have 2 times 1, which is 2. So we have 16 plus or minus the square root of 256 minus 256 divided by 2. So that's 16 plus or minus the square root of 0 divided by 2. The square root of 0 is 0, so we only have one answer option here because 16 plus 0 is the same as 16 minus 0. So we have 16 divided by 2, which is 8. So x equals 8. All right, I want to talk about the discriminant here. This is the second part of our objective. The discriminant is what tells you how many solutions your quadratic equation will have. So underneath that radical is what describes the roots or the zeros or the solutions, and that part is called the discriminant. So the b squared minus 4ac is the discriminant. So if we take a look here, we have some notes that you might want to jot down, but if your discriminant ends up being greater than 0, you are going to have two real roots. Okay, so if whatever you sub in for A, B, and C, you get that number and it is greater than 0, you know that you should solve for two real roots. If your discriminant equals 0, then you only have one real root. So if you sub in A, B, and C, and you get 0 for that, then you have only one real root. And if your discriminant ends up less than 0, you have no real roots. It does not cross the x-axis. So when you sub in A, B, and C, you get some number less than 0, and there are no real roots. Okay? So if I take a look here at this equation, this quadratic equation of 4y squared plus 3y minus 1 equals 0, and I want to determine how many solutions there are using the discriminant, I first want to remember that A equals 4, B equals 3, and C equals negative 1. So now I'm going to find the discriminant. So when I find the discriminant, I do b squared minus 4ac. So that's 3 squared minus 4 times negative 1. So that is 9 plus 16, which is 25. And if it is greater than 0, I know that I have two real roots. So because the discriminant is 25, if I were to solve that quadratic formula, or that quadratic equation using the formula, I know that I should get two answers, two real solutions. Okay, let's take a look at this one. If I have 4x squared minus x plus 5, I know that A equals 4, B equals negative 1, and C equals 5. We want to look at the discriminant to decide how many real solutions this quadratic has. So I would say b squared minus 4ac, so that would be negative 1 squared minus 4 times 5. So that's 1 minus 80, which is negative 79, and negative 79 is less than 0, so there are no real roots. There are 0 real roots. So if I were to solve that, there are no real roots for that quadratic. All right, I would like you to go ahead and try to find the discriminant by yourself on these two problems. Make sure you put them in standard form for the quadratic equation. Go ahead and pause the video while you do that work, And then when you come back, I will go over what the discriminant is to describe how many real solutions each of these quadratic equations have. All right, if you take a look here, for number 1, you should have determined that there were 2 real roots. So if you put that in standard form, you want to subtract the 5 from both sides, so you get 2x squared minus 4x minus 5 equals 0. So the a term is 2, the b term is negative 4, and the c term is negative 5. So you would take negative 4 squared minus 4 times 2 times negative 5. Negative 4 squared is 16, and negative 4 times 2 is negative 8, times negative 5 is positive 40. So 16 plus 40 gives us that the discriminant is equal to 56. 56 is greater than 0, so this has 2 real roots. All right, let's take a look at the second one. For this one, you had to do a couple things to get it into standard form. You had to subtract 8x from both sides and add 4 to both sides. So you get 4x squared minus 8x plus 4 equals 0. So the a term is 4, the b term is negative 8, and the c term is positive 4. So negative 8 squared minus 4 times 4 times 4. Well, negative 8 squared is 64, and negative 4 times 4 is negative 16. Negative 16 times 4 is negative 64. So for the discriminant, we have 64 minus 64, which is 0. And if the discriminant equals 0, we know there's only one real root. So there's one real root for that quadratic equation. All right, so hopefully that gives you a small look into how to use the quadratic formula and the discriminant to solve a quadratic equation and to determine how many real roots there are for that quadratic equation. So you should be able to solve quadratic equations using the quadratic formula and find the number of solutions for a quadratic equation. So at this point, you are done watching the video. Feel free to keep the video up and refer back to the work or look back to the work if you need to, but go ahead and go up and get the 9-6 worksheet to work on how to solve a quadratic equation using the quadratic formula. I will be back to class tomorrow, and we will have some time to kind of wrap up our thoughts with that. So make sure that tonight as you're working on your work or in class today as you work on your work, you put a star by anything that you have a question about, and I will be happy to help you tomorrow in class.